Earth is the third planet from the Sun, the only world we know of that harbors life, and the most geologically active, biologically complex, and frankly improbable planet in the solar system. We live on it, and most of us know almost nothing about it. It is older than you think, stranger than you think, and more extraordinary than most people ever stop to appreciate. Here are 50 facts about the planet you call home that will make you see it completely differently. Number 1. Earth is not a perfect sphere. It bulges at the equator due to its rotation, making the equatorial diameter about 43 kilometers wider than the polar diameter. This shape is called an oblate spheroid. As a result, the point on Earth's surface farthest from the center of the planet is not the top of Mount Everest. It is the summit of Mount Chimborazo in Ecuador, which sits closer to the equatorial bulge and therefore protrudes further from Earth's center than Everest does, despite being several kilometers shorter in absolute elevation. Number 2. Earth is 4.5 billion years old. Earth formed approximately 4.54 billion years ago from the cloud of gas and dust that surrounded the young sun. To put that in perspective, if Earth's entire history were compressed into a single 24-hour day, the first humans would appear in the final 2 seconds before midnight. The dinosaurs would go extinct around 11 hours and 39 minutes. The oldest rocks ever found on Earth date back about 4 billion years, and the oldest crystals, tiny zircon grains found in Australia, have been dated to 4.4 billion years old. Number 3. Earth was hit by another planet. The Moon did not simply materialize. The leading scientific theory for its formation is the giant impact hypothesis, which proposes that early in Earth's history, roughly 4.5 billion years ago, a Mars-sized planet called Theia collided with the proto-Earth in a catastrophic impact. The collision was so violent that it melted both bodies and threw an enormous cloud of vaporized rock into orbit around Earth. Over thousands of years, that debris coalesced into the Moon. The Moon is, in a very real sense, made partly of Earth. Number 4. The Moon is slowly moving away from Earth. The Moon is not staying put. It is very gradually moving away from Earth at a rate of approximately 3.8 centimeters per year, about the same rate at which human fingernails grow. This recession is caused by tidal interactions between Earth and the Moon. As it moves away, the Moon's gravitational influence on Earth's rotation is gradually slowing Earth's spin. Days on Earth are getting longer by about 1.4 milliseconds per century. Billions of years ago, a day on Earth lasted only about 6 hours. Number 5. Earth has a liquid iron outer core. At the center of Earth is a solid inner core of iron and nickel approximately 2,440 kilometers in diameter, surrounded by a liquid outer core of molten iron and nickel about 2,200 kilometers thick. The movement of liquid iron in the outer core, driven by heat and Earth's rotation, generates electric currents that produce Earth's magnetic field. Without this magnetic field, the solar wind would strip away Earth's atmosphere, liquid water could not exist on the surface, and life as we know it would be impossible. Number 6. Earth's magnetic poles wander and occasionally flip. Earth's magnetic North Pole is not the same as its geographic North Pole, and it is not stationary. It has been drifting across the Arctic for centuries, and in recent decades the drift has accelerated to roughly 50 kilometers per year. More dramatically, Earth's magnetic field periodically reverses entirely. North becomes south, and south becomes north. This has happened hundreds of times in Earth's history, most recently about 780,000 years ago. During a reversal, the magnetic field weakens significantly and becomes chaotic for thousands of years before re-establishing in the opposite direction. Number 7. Earth is the densest planet in the solar system. Despite not being the largest planet, Earth is the densest of all 8 planets. Its average density is about 5.5 grams per cubic centimeter, largely because of its large iron core. Saturn, by comparison, has a density lower than water. Earth's high density is one of the reasons it retained its atmosphere and developed the geological processes that made life possible. The composition of Earth, with its heavy metallic core and rocky mantle, makes it an unusually substantive and gravitationally powerful body for its size. Number 8. Earth is the only planet in the solar system with plate tectonics. Earth is the only planet we know of with active plate tectonics, the process by which the crust is divided into large, rigid plates that move, collide, separate, and slide past each other. This process recycles carbon from the atmosphere into the crust and back again, regulating Earth's temperature over millions of years. It builds mountains, creates ocean basins, triggers earthquakes and volcanoes, and has fundamentally shaped every major feature of the planet's surface. Plate tectonics may be one of the reasons Earth is habitable. Without it, the carbon cycle would break down and the planet might freeze or overheat. Number 9. Most of Earth's surface has never been seen by human eyes. About 71% of Earth's surface is covered by ocean. Of that ocean, roughly 80% remains unmapped and unexplored in detail. We have better maps of the surface of Mars, the Moon, and Venus than we do of our own ocean floor. The deep sea is home to the largest ecosystem on Earth, spanning abyssal plains, mid-ocean ridges, hydrothermal vents, and submarine mountain ranges. Creatures are still being discovered there regularly, including species that look like nothing previously known to science. Number 10. Earth has a second quasi-moon. Earth has one true moon, but it also has a companion. The asteroid 3753 Kruthner, discovered in 1986, is sometimes described as a second moon. It does not orbit Earth in the traditional sense, but follows a complex horseshoe-shaped path around the Sun that keeps it in a long-term gravitational relationship with Earth. Several other small asteroids have similar relationships with our planet. Earth is not quite as alone in space as it might appear. At number 11, the atmosphere is thinner than you think. Earth's atmosphere extends hundreds of kilometers above the surface, but 99% of the atmosphere's total mass is concentrated in the lowest 32 kilometers. The layer that sustains all weather, all breathing, all human life, the troposphere, is only about 12 kilometers thick on average. If Earth were the size of a standard classroom globe, the entire breathable atmosphere would be thinner than a layer of paint on the surface. It is an extraordinarily thin shell keeping every living thing alive. Number 12. A lightning strikes Earth about 100 times every second. At any given moment, about 2,000 thunderstorms are active around the world, collectively producing around 100 lightning strikes per second, or roughly 8 million per day. Each bolt of lightning heats the surrounding air to about 30,000 Kelvin, 5 times hotter than the surface of the Sun, in a fraction of a second. Lightning was likely one of the energy sources that drove the chemical reactions that created the first organic molecules on early Earth, potentially playing a role in the origin of life itself. Number 13. Earth has an oxygen atmosphere because of life. Earth's oxygen-rich atmosphere did not always exist. For the first 2 billion years of Earth's history, the atmosphere contained almost no free oxygen. Then, roughly 2.4 billion years ago, a type of photosynthetic bacteria called cyanobacteria began producing oxygen as a waste product in enormous quantities. This event, known as the Great Oxidation Event, fundamentally transformed the atmosphere. Oxygen went from being essentially absent to making up about 21% of the atmosphere. For most species alive at the time, it was a mass extinction event. Oxygen was poison to them. For the life that came after, it was the foundation of everything. Number 14. The Sahara Desert was once a lush green savanna. About 11,000 years ago, the Sahara Desert was green. Monsoon rains brought by a shift in Earth's orbital cycle transformed the largest hot desert on the planet into grasslands, forests, and lakes teeming with wildlife. Hippos swam in rivers where there is now only sand. People lived and farmed across the Sahara. Then, roughly 5,500 years ago, the orbital cycle shifted again, the monsoons retreated, and the Sahara dried out almost completely within a few thousand years. The bones of hippos and the remnants of human settlements lie beneath the desert sand today. Number 15. Earth has had multiple mass extinction events. Life on Earth has faced at least 5 major mass extinction events, each of which wiped out a substantial proportion of all species on the planet. The most severe, the end Permian extinction around 252 million years ago, killed approximately 96% of all marine species and 70% of land vertebrate species. The most famous, the end Cretaceous extinction 66 million years ago, ended the reign of the non-avian dinosaurs when an asteroid about 10 kilometers across struck what is now the Yucatan Peninsula in Mexico. Each mass extinction was followed by a recovery that eventually produced greater biological diversity than existed before. Number 16. The asteroid that killed the dinosaurs struck with the force of billions of nuclear bombs. The Chicxulub impactor, the asteroid that triggered the end Cretaceous mass extinction 66 million years ago, was estimated to be approximately 10 to 15 kilometers in diameter. When it struck Earth at around 20 kilometers per second, it released energy equivalent to roughly 10 billion times the energy of the atomic bomb dropped on Hiroshima. The impact triggered earthquakes, megatsunami, wildfires, and threw enough debris and sulfur into the atmosphere to block sunlight globally for years, causing temperatures to plunge and collapsing food chains around the world. Number 17. Earth has been completely frozen at least twice. The snowball Earth hypothesis proposes that on at least two occasions, roughly 700 million years ago and 600 million years ago, Earth was almost entirely covered in ice from the poles to the equator. Average global temperatures may have reached minus 50 degrees Celsius. The oceans froze over entirely or nearly so. How life survived is still debated, but survive it did, and the warming that eventually ended each snowball Earth event, driven by volcanic carbon dioxide building up in the atmosphere, may have triggered some of the most dramatic evolutionary diversification events in the history of life. Number 18. Earth has more trees than there are stars in the Milky Way. A 2015 study estimated that Earth has approximately 3 trillion trees. The Milky Way galaxy contains somewhere between 100 and 400 billion stars. That means Earth has somewhere between 7 and 30 times more trees than our galaxy has stars. Of course, the number of trees has declined significantly from pre-human levels. The same study estimated that humanity has reduced the global tree count by approximately 46% since the start of civilization. There were once nearly 6 trillion trees on Earth. Number 19. Earth experiences more than 1 million earthquakes a year. Seismographs around the world detect more than 1 million earthquakes every year. The vast majority are too small to be felt by humans. About 20,000 are strong enough to be noticed without instruments. Major earthquakes capable of causing significant damage occur several times per year. The energy released by all earthquakes combined in a year is roughly equivalent to about 200,000 nuclear bombs. The planet is under constant geological stress, its tectonic plates grinding, colliding, and shifting every moment of every day. Number 20. The deepest point on Earth is in the Pacific Ocean. The Challenger, deep located in the Mariana Trench in the western Pacific Ocean, is the deepest known point on Earth's surface. It lies approximately 10,935 meters below sea level. If Mount Everest were placed at the bottom of the Mariana Trench, its summit would still be more than a kilometer underwater. The pressure at the bottom of the Challenger Deep is about 1,086 times the atmospheric pressure at sea level. Despite these extreme conditions, life exists there. Microorganisms, crustaceans, and other creatures have been found living in the deepest parts of the trench. At number 21. Earth's oceans are still largely unexplored. The global ocean covers about 361 million square kilometers and has an average depth of about 3,688 meters. Yet only a small fraction of it has been directly explored. The technology required to reach the deepest parts of the ocean is in some ways more demanding than the technology required to send spacecraft to other planets. The deep ocean is cold, dark, and under crushing pressure. Yet it contains ecosystems of extraordinary complexity and diversity, from bioluminescent creatures drifting through the midnight zone to tube worms and giant clams clustered around hydrothermal vents on the seafloor. Number 22. Earth is the only planet known to have plate tectonics fueled by water. Water plays a crucial but often overlooked role in Earth's plate tectonics. Water is incorporated into oceanic crust through hydrothermal circulation at mid-ocean ridges. And when that crust subducts back into the mantle, the water lowers the melting point of the surrounding rock, enabling magma to form and volcanoes to erupt. Water also lubricates the faults along which tectonic plates slide. Earth's water cycle and its geological cycle are not separate systems. They are deeply intertwined, and the presence of liquid water on the surface may be one of the key reasons Earth's plates are mobile in the first place. Number 23. The Amazon rainforest produces its own rain. The Amazon rainforest generates a significant portion of its own rainfall through a process sometimes called flying rivers. Trees in the Amazon absorb enormous quantities of water through their roots and release it into the atmosphere through their leaves via a process called transpiration. The Amazon rainforest releases so much water vapor that it creates atmospheric rivers. streams of moisture flowing through the sky that carry water across the continent and provide rainfall to regions far beyond the forest itself. The forest is, in a very real sense, a self-sustaining climate system as well as an ecosystem. Number 24. Earth's days are getting longer. Earth's rotation is gradually slowing down due to tidal friction caused by the Moon's gravitational pull. As a result, days on Earth are getting very slightly longer over time. The effect is tiny by human standards, about 1.4 milliseconds per century, but over billions of years it adds up enormously. In the distant past, when the Moon was closer and its tidal influence stronger, days on Earth lasted only a few hours. Eventually, if the Sun does not expand and engulf the Earth first, the slowing would continue until Earth's rotation matches the Moon's orbital period, keeping one face permanently locked toward the Moon. Number 25. Earth is passing through the Milky Way at enormous speed. Earth orbits the Sun at about 107,000 kilometers per hour. The Sun, in turn, orbits the center of the Milky Way galaxy at about 828,000 kilometers per hour. The galaxy itself is moving relative to other galaxies at speeds of hundreds of kilometers per second. Add it all up, and at any given moment, you are sitting on a rock, hurtling through the universe at a combined speed that makes any human-made vehicle look comically slow. The only reason this does not feel dramatic is that the distances involved are so vast that the motion is imperceptible without instruments. Number 26. Earth has had more than one North Pole. Earth's geographic North Pole, defined by the axis around which the planet spins, has not always been in the same place. A phenomenon called true polar wander describes the slow shift of Earth's rotational axis relative to the planet's crust over geological timescales. If a large mass, such as a growing ice sheet or a chain of volcanoes, redistributes enough weight across the planet, the rotational axis will reorient itself to seek a new equilibrium. Evidence suggests this has happened multiple times in Earth's history, potentially repositioning the poles by tens of degrees. Number 27. Earth was once purple. Before plant life covered the land and cyanobacteria dominated the oceans, early life on Earth may have relied on a pigment called retinal rather than chlorophyll to harvest sunlight. Retinal absorbs green light and reflects red and violet wavelengths. If the early oceans were dominated by retinal-based microbes, they would have appeared deep purple or violet from space rather than the blue and green we see today. The purple Earth hypothesis remains speculative, but has gained scientific attention as a possible explanation for why life initially evolved to use retinal, a less efficient light-harvesting molecule than chlorophyll. Number 28. The oceans formed from asteroids and comets. Earth formed in a region of the solar system where temperatures were too high for water ice to condense. Where then did Earth's oceans come from? The leading answer is that water was delivered to Earth during a period of intense asteroid and comet bombardment in the early solar system. Asteroids, particularly a type known as carbonaceous chondrites, contained significant quantities of water locked in their minerals. When they struck the early Earth, they delivered that water to the surface. The hydrogen isotope ratios in Earth's oceans match those found in carbonaceous chondrite meteorites, supporting this theory. Number 29. Earth has a moon that is remarkably large for its host planet. The moon is unusually large relative to Earth compared to the moons of other planets. The ratio of the moon's diameter to Earth's diameter is about 1:4, the largest such ratio for any planet-moon pair in the solar system, with the possible exception of Pluto and its moon Charon. This disproportionately large moon has had profound consequences for Earth. The moon stabilizes Earth's axial tilt, keeping it within a relatively narrow range of about 22 to 24.5 degrees over long periods. Without the moon's stabilizing influence, Earth's tilt might vary chaotically, causing extreme climate swings that could make complex life much harder to sustain. Number 30. Earth has a natural nuclear reactor. Roughly 2 billion years ago, in what is now Gabon in Central Africa, conditions were just right for naturally occurring uranium deposits to sustain self-regulating nuclear fission chain reactions. These natural nuclear reactors, discovered in the 1970s at a site called Oklo, operated for hundreds of thousands of years, producing heat and neutrons just as a human-built reactor does, but entirely without any artificial intervention. They are the only known natural nuclear reactors in Earth's history, and they only became possible because 2 billion years ago the concentration of fissile uranium, 235 in natural uranium, was high enough to sustain the reaction. At number 31. Earth is almost entirely untouched inside. Despite all of human civilization and technology, the deepest hole ever drilled into Earth's crust is only about 12 kilometers deep. This was the Kola Superdeep Borehole in Russia, drilled between 1970 and 1994, and still the deepest artificial point on Earth. Earth's radius is about 6,371 kilometers. The deepest hole ever drilled penetrates less than 0.2% of the way to the center. The vast majority of our planet's interior has never been directly sampled and remains known only through seismic data and theoretical models. Number 32. Earth humes. Earth produces a constant, extremely low-frequency vibration called the Earth's hum or the microseismic background. It is not caused by earthquakes or human activity. It is a continuous, gentle oscillation of the planet itself at frequencies far below the threshold of human hearing. The exact cause is still debated, but the leading explanation involves ocean waves interacting with the seafloor, creating pressure variations that set the entire planet vibrating. Earth is always humming, imperceptibly, as the ocean churns against the crust. Number 33. The Sahara sends dust to the Amazon. Every year, the Sahara Desert sends an estimated 22,000 tons of dust across the Atlantic Ocean to the Amazon rainforest. The dust, lifted by desert winds and transported by high-altitude air currents, contains phosphorus and other nutrients that are essential to the health of the Amazon ecosystem. The Amazon soils are ancient and heavily leached of nutrients by rainfall, and the annual dust delivery from the Sahara replenishes a significant portion of what is lost. A desert in Africa is fertilizing a forest in South America across 5,000 kilometers of open ocean. Number 34. Earth's interior is as hot as the sun's surface. The temperature at Earth's inner core is estimated to be approximately 5,100 to 6,000 degrees Celsius. The surface of the Sun is about 5,500 degrees Celsius. Earth's core and the Sun's visible surface are at roughly the same temperature. The core is kept this hot partly by residual heat from Earth's formation and partly by the radioactive decay of elements such as uranium, thorium, and potassium in the interior. This internal heat drives the movement of tectonic plates, fuels volcanoes, and ultimately makes Earth the geologically active planet it is. Number 35. Earth had a different oxygen level in the past. The oxygen content of Earth's atmosphere has not always been 21%. During the Carboniferous period, roughly 300 million years ago, oxygen levels reached approximately 35%, significantly higher than today. This elevated oxygen level is thought to have enabled insects to grow to extraordinary sizes. Giant dragonflies with wingspans of up to 70 centimeters flew through Carboniferous forests. Millipedes grew to over 2 meters in length. The physical limit on arthropod size is partially determined by how efficiently oxygen can diffuse through their respiratory systems, and higher atmospheric oxygen directly enabled larger body sizes. Number 36. Earth has tidal forces from the Sun as well as the Moon. Most people know that the Moon causes Earth's tides. Fewer people know that the Sun also exerts tidal forces on Earth, though they are weaker, about 46% as strong as the Moon's tidal influence. When the Sun, Earth, and Moon align during a new or full moon, their tidal forces combine to create spring tides, the largest tidal ranges. When the Sun and Moon are at right angles relative to Earth, their tidal forces partially cancel, creating the smaller Eneap tides. The interplay between these two celestial bodies has shaped coastal ecosystems and influenced ocean circulation for billions of years. Number 37. Earth receives a precisely right amount of energy from the Sun. Earth orbits the Sun in what astronomers call the habitable zone, the range of orbital distances at which liquid water can exist on a planetary surface. Venus is slightly too close, Mars slightly too far. Earth sits almost exactly right, although the precise boundaries of the habitable zone depend on many factors, including atmospheric composition, cloud cover, and planetary geology. This fortunate position is sometimes called the Goldilocks zone, not too hot, not too cold, but just right. It is one of several factors that make Earth's habitability remarkably finely tuned. Number 38. Earth is struck by tons of space material every day. Every day, Earth is bombarded by material from space. The vast majority of this is microscopic dust and tiny meteoroids that burn up completely in the atmosphere. But the total mass of material falling to Earth each day is estimated at between 100 and 300 tons. Most of it arrives so gradually and in such small pieces that it goes completely unnoticed. Over the course of Earth's history, this constant rain of extraterrestrial material has delivered significant quantities of organic compounds, metals, and potentially even complex molecules relevant to the origin of life. Number 39. Earth has a continent that was entirely underwater. Zealandia is a largely submerged continental mass in the southwestern Pacific Ocean. It includes New Zealand and New Caledonia above the surface, but about 94% of it lies beneath the ocean. Geologists formally recognized Zealandia as a continent in 2017, making it the seventh and by far the smallest and most submerged continent on Earth. Zealandia broke away from Gondwana, the ancient supercontinent that also included Antarctica, Australia, South America, Africa, and India about 85 million years ago, and gradually sank as it drifted. Number 40. Earth had a supercontinent called Pangaea. About 300 million years ago, all of Earth's landmasses were joined together in a single supercontinent called Pangaea. Before Pangaea, there were earlier supercontinents, including Rodinia about 900 million years ago and Columbia about 1.8 billion years ago. Pangaea began breaking apart about 200 million years ago, eventually producing the continents we know today. The process is ongoing. In roughly 250 million years, the continents will once again converge to form a new supercontinent, sometimes called Amasia or Pangaea Proxima, as the Atlantic Ocean closes and the Pacific shrinks. At number 41, the Earth breathes. From space, satellites can observe Earth's vegetation changing with the seasons. In the northern hemisphere, spring and summer, as plants grow and absorb carbon dioxide, the concentration of carbon dioxide in the atmosphere measurably drops globally. In autumn and winter, as plants die back and decompose, carbon dioxide levels rise again. This annual oscillation in global carbon dioxide is sometimes described as the Earth breathing, a planet-wide cycle of exhalation and inhalation driven by the growth and decay of plants. The amplitude of this seasonal breathing has increased over recent decades as vegetation in the northern hemisphere has expanded. Number 42. Deep-sea hydrothermal vents may have given birth to life. The origin of life on Earth is one of science's great unsolved questions, but one of the most compelling current hypotheses points to deep-sea hydrothermal vents. These underwater volcanic fissures release superheated, chemical-rich water into the cold, deep ocean, creating steep gradients of temperature and chemistry that could have powered the first biochemical reactions. Laboratory experiments have shown that many of the basic building blocks of life, amino acids, lipids, and simple nucleotides, can form spontaneously under conditions resembling hydrothermal vent environments. Life may have begun not under sunlight, but in total darkness at the bottom of the sea. Number 43. Earth is the only planet known to have a carbon cycle. The carbon cycle is the process by which carbon moves between the atmosphere, the ocean, living organisms, and the rock of Earth's crust over millions of years. Carbon dioxide is pulled from the atmosphere by rainfall, which makes carbonic acid that slowly weathers rock, carrying calcium carbonate into the ocean where it is incorporated into shells and eventually subducted into the mantle. Volcanoes then release it back into the atmosphere. This long-term geological carbon cycle has kept Earth's temperature within a range suitable for liquid water for billions of years, acting as a natural thermostat. No other planet is known to have this self-regulating system operating in full. Number 44. Earth has more biological diversity than we have catalogued. Scientists have formally described and named approximately 8.7 million species of living organisms on Earth. But estimates of the actual total number of species range from 8.7 million to over 1 trillion when microbial species are included. The vast majority of Earth's species have never been studied, named, or even seen. The deep ocean, the soil, and the rainforest canopy all harbor enormous numbers of unknown species. Earth remains, in a very real sense, a largely unknown planet biologically, despite being the most studied world in existence. Number 45. Earth once orbited closer to the Sun. The gravitational dynamics of the early solar system were chaotic and complex. As the planets settled into their current orbits over hundreds of millions of years, they migrated from where they originally formed. Earth's orbit has shifted over time, and models suggest Earth may have formed slightly closer to the Sun than it currently sits, before migrating outward as Jupiter and the outer planets rearrange themselves. This orbital migration shaped the delivery of water and organic material to early Earth and influenced the conditions under which life first appeared. Number 46. The North Pole is an ocean, not a continent. Antarctica at the South Pole is a continent, a massive landmass buried under kilometers of ice. The Arctic at the North Pole is the opposite. It is an ocean, the Arctic Ocean, covered in sea ice. There is no land beneath the North Pole. This fundamental geographic difference between the two poles has enormous consequences for climate, ecology, and geopolitics. The Arctic Ocean is largely enclosed by the land masses of North America, Europe, and Asia, making it particularly sensitive to changes in ocean circulation. The Antarctic ice sheet, being land-based, contributes directly to sea level rise when it melts in a way that floating Arctic sea ice does not. Number 47. Earth is a water world in an unusual sense. Of all the water on Earth, about 97% is saltwater in the oceans. Of the remaining 3% that is freshwater, about 69% is locked in glaciers and ice caps, 30% is groundwater, and less than 1% is accessible in rivers, lakes, and the atmosphere. The freshwater that sustains nearly all of terrestrial life and all of human civilization represents an extraordinarily thin sliver of Earth's total water budget. The rivers and lakes that seem so abundant and permanent from a human perspective contain less than 0.01% of all water on Earth. Number 48. Earth has an ozone layer that makes complex life possible. The ozone layer, a region of the stratosphere between about 15 and 35 kilometers altitude where ozone molecules are concentrated, absorbs most of the sun's ultraviolet radiation before it reaches the surface. Without the ozone layer, UV radiation at the surface would be intense enough to damage DNA rapidly, making life on land extraordinarily difficult or impossible. The ozone layer was essentially created by life itself. The oxygen produced by photosynthetic organisms over billions of years built up the atmospheric oxygen that UV radiation then converted into ozone in the stratosphere. Number 49. Earth will eventually be engulfed by the sun. In approximately 5 billion years, the sun will exhaust its hydrogen fuel and expand into a red giant, growing to perhaps 200 times its current diameter. At that point, it will engulf Mercury and Venus and may reach close enough to Earth to either engulf it entirely or strip away its atmosphere and oceans, making the surface uninhabitable long before the physical absorption. The Earth as we know it has a finite lifespan. But on a timescale of 5 billion years, so much else will have changed, biologically, geologically, and perhaps technologically, that predicting what life or civilization might look like by then is essentially impossible. Number 50. Earth is the only known planet where you can witness a total solar eclipse. This is one of the most remarkable coincidences in the solar system. The Sun is approximately 400 times wider than the Moon, but it is also approximately 400 times farther from Earth. The result of this near-perfect ratio is that from Earth's surface, the Moon and the Sun appear to be almost exactly the same size in the sky. During a total solar eclipse, the Moon fits almost perfectly over the disk of the Sun, revealing the solar corona, the outer atmosphere of the Sun, which is otherwise invisible. This coincidence is unique to Earth. No other planet has a moon in precisely the right size and distance ratio to produce this effect. We live on the only world in the solar system from which a total solar eclipse is visible, and it is, by any measure, one of the most extraordinary sights in the known universe. And there you have it. 50 facts about the planet you are standing on right now. Earth is ancient, violent, improbable, and extraordinary. It has survived asteroid impacts, global glaciations, mass extinctions, and it is still producing new landscapes and new surprises. There is no planet like it that we know of, so hit that subscribe button to take care of it. And see you in the next video.